So today we are going to give a talk on upgrade and high availability of cluster using logical replication. So let's start with the talk. So yeah, this is our agenda for today. So first I will go through some introduction, then I will go to upgrade of streaming replication clusters. Then I will be explaining about upgrade of logical replication clusters. Then Nisha will take over for the high availability of the replication clusters. So let's go to the introduction part. So yeah, so starting first let's understand what is replication. So basically replication is the process of copying of data. So in case of Postgres, it's like copying our data from a cluster to another cluster, like copying our data from our upstream to our downstream. And in Postgres, there are basically two types of replication. One is streaming replication, another is logical replication. So main difference between both is like what kind of data they send during replication. So during streaming replication, they usually send the exact WAL files, whereas in logical replication, these WAL files are processed and a special replication message is sent. So here, let's see with one example. So suppose there is one application which sends some query to the upstream. So what happens during streaming replication? A binary stream is sent during the streaming replication, and yeah, this is exact. It is the exact WAL files. And during logical replication, we decode that WAL files and send a replication message from the upstream to the downstream for the replication. Okay. So now let's understand upgrade in Postgres. So in Postgres, we have an inbuilt tool called PG upgrade, which is used to upgrade the clusters in Postgres. So why we need to upgrade in Postgres? So basically every year new releases happen in Postgres community. So to use the new feature, latest feature, we generally upgrade our clusters. And also a major version is supported for 5 years by the community. So so to upgrade those clusters also we use this upgrade PG upgrade tool. So yeah. So there are some challenges in during upgrade. So during upgrade we have to stop our server, because to mitigate the risks, like during upgrade user do not perform any operations, or yeah, there are no operations like auto vacuum. To prevent that scenarios, we need to stop the instance during the PG upgrade. And yeah, one more drawback of PG upgrade is that during the migration, it does not migrate the replication slots. And yeah, other thing is that the major versions can have different they can have different layout for the system catalogs, and they can have different WAL formats. So this is one issue. Like, and yeah, one main issue is that during upgrade, the streaming replication is broken, because streaming during the basic requirement for streaming replication is that both the cluster, the upstream and the downstream, both should be on same major version of Postgres. And yeah, but PG upgrade supports only upgrade of one cluster at a time. So yeah, so that's why when we want to upgrade a streaming replication setup, we upgrade a single node. So that way that replication is broken during streaming replication. So what should we use for that case? We can use a logical replication. So why should we use logical replication for updates? Like logical replication works across different major versions. Suppose the upstream can be in PG16, the downstream can be in PG12, and then also that replication is supported. We can replicate data from PG16 to PG12 using logical replication. Yeah. And also so different major version can have different wall formats, so this does not affect logical replication. So yeah, so basically because of these points, logical replications can be used during upgrade to reduce the downtime. Now let's proceed to the next part. So it's like upgrading streaming replication clusters. So here I am taking an example, like initially we have a setup of streaming replication in PG12, and we want to upgrade this to a setup of PG16. Now, yeah, so for the demonstration, I will be using the term node 1 and node 2. So I will be using node 1 for the primary and node 2 for the standby node. Yeah, so let's start. So yeah, for this step, first what I will do, that we will create a replication slots for all the databases on the node 1. Then we will create publication for all the tables on node 1. And yeah, then we promote the standby node, the node 2 to primary. And while doing that, we should keep a track of the LSN on the node 1. So, and in next step, what we will do, for if all the replication slots, we will advance the replication slot to that particular LSN value that we read previously. Now we create subscription for all the databases. So now logical replication will be set up between primary and the logical replication will be set up between the node 1 and node 2. So yeah, now we are going to upgrade the clusters. So we will start with upgrading the node 2. So we stop the node 2 and run pg upgrade command for that node. And yeah, this command upgrades the node 2 from pg12 to pg16. Now during the upgrade, what happens is like, so till pg16 the replication states and relations are not preserved while upgrade, and while for the subscriber we do not have the relations. I'm sorry. Okay, so during the upgrade of the node 2, that is a subscriber. So yeah, during the upgrade we do not preserve the states and the relations of the tables, or we do not have the LSN value till which the replication has already been done. So we do not preserve that value during the PG upgrade, so that value is lost. So that's why after the upgrade we need to create a fresh replication setup. So for that we need to truncate all the tables on the node 2 and recreate the subscription by dropping the subscription and creating a fresh subscription. So after creating a fresh subscription, the whole copy process, the initial sync of the data will happen again. And yeah, that will happen again, and this the data will be replicated to PG16. Now suppose any application which is using the connection string of this node 1, we will change the connection string from node 1 to node 2, and we will stop the node 1 server, and then we will take a backup of node 2 here. So yeah, and that's where we will get a streaming replication setup here, and then we will drop all the subscription on the node 2. So by following these steps, we can upgrade a streaming replication cluster using logical replication with less downtime. Now during this upgrade, we saw some problems, like we have to create replication slots, we have to create publications, and we have to adjust the LSN values. And also during the upgrade of the subscriber, the informations related to the LSN and the state of the tables are being lost. So so for that we have to drop the subscription, truncate the table and recreate the subscription. So these are some major problems, and this can be a complex process and a time consuming process. So there are some new features added in PG17, so which can mitigate these issues. So one feature is like a new tool is added called PG Create Subscriber. So what does PG Create Subscriber do? It converts a physical standby to a logical subscriber. So how it basically does that, at a certain point it checks if this standby is caught up, and from that point it stores that point as a consistent LSN value, and then it creates a subscription. After on that, so the data after that point are replicated using the logical replication. So so this is the syntax we use for PG Create Subscriber. So we can specify the database names for which we want to run this tool, and we specify the data directive of the standby node, and we specify the connection string of the primary node. Okay. So apart from this, PG Create Subscriber have some other advantage, like PG Create Subscriber can speed up the process of initial logical replication setup. So basically, for normal logical replication setup, the initial sync is done by a copy command. So this copy command, the time for execution of this copy command depends on number of tables present in the initial database. So suppose our primary cluster is having a large number of data. So for that case, it can take much amount of time. So we can use PG Create Subscriber. So for using PG Create Subscriber, we will first initially set up a standby replication, so streaming replication. So that in that replication, the direct WAL files are sent. So it will be much faster than the copy command. And then we can convert that streaming replication to logical replication using this tool. So here you can see a graph where we have done the initial sync of using logical replication and using PG Create Subscriber. The red column shows the data for normal logical replication, and the orange column shows the data for using PG Create Subscriber. And you can see as the data size of the tables increases, the difference in execution time also means we can see a huge difference. So in this way, PG Create Subscriber can speed up the initial sync up of logical replication. And now other advantage is that if we use PG Create Subscriber, then during the initial sync, we would require less disk resources, because suppose we have a very large database and we set up a logical replication. So copy command will run, and that copy command will take much time to catch up. Now assume parallelly the user is doing some operations on the database. So that operations are not immediately replicated because initial sync up is being caught up. The copy command is in running state. So that commands are stored in form of the WAL records, and that WAL records can grow and can cause the disks to fill up, which can create problem. But if we use the PG Create Subscriber here, so we will not face such issue. Now moving on to the next slide. So other feature which is added in PG17 is like till PG16 during upgrade only subscription metadata information was stored. We didn't have the states or LSN values. So So since we didn't had the list of relations and their state, it was not possible to restart the subscription without losing any data. So we have to recreate the subscription from scratch. So that's why in the PG17, during PG upgrade, we are storing that list of states and relations which are stored in PG subscription rail system catalog. So that is being preserved, and also the replication origin, and or we can say the LSN up to which replication have been done, that LSN value is stored. So yeah, so now after upgrade, we can simply the replication can simply move on. We don't have to do the additional steps. So now, considering the new features, let's see what is the improvement in these steps. So since this feature are used in introduced in PG17, so I am considering so this feature will be present in PG17. So I am considering the upgrade from PG17 to PG latest, which will be the latest version. So suppose initially we have a PG17 streaming replication setup, and yeah, so here we run a PG create subscriber on the streaming replication setup. So it will be converted to logical replication setup. Now we just need to stop the node 2 and upgrade it. So once it is upgraded, since the PG subscription real data is preserved here, we don't have to do the additional steps. And yeah, that logical replication is still there with yeah. So that's why we can see that we don't have to do that additional steps here. And yeah, the node 2 is upgraded from PG17 to PG latest. And yeah, now we take a PG base backup of the node 2, and we can establish the streaming replication and drop all the subscription on the node 2. So that's we can see that the steps is much reduced in case of PG17. Now moving on to upgrade of logical replication clusters. So yeah, for logical replication also, let's assume we have the same setup. We have a PG12, we have a logical replication setup at PG12. We have a publisher and a subscriber. So we need to upgrade it to PG16. So for that, what steps we use? Like, we disable all the subscription on the node 2. We disable it because we don't want the connection to happen in between the upgrade. So it can cause some inconsistency. So yeah. So here we stop the for the next step. Yeah, so here we stop the publisher server and then upgrade it. So while upgrade, we see that the replication slots are not being retained while upgrading the publisher. Yeah, so what we need to do is that we have to recreate the replication slots and advance the replication slot, and then on the subscriber side we need to stop the server and upgrade the server. So this way that subscriber is upgraded, but for until PG16 till PG16 we don't replicate the PG subscription real data. So yeah, we need to recreate all the subscription for that. And also during the upgrade of publisher, during the upgrade process, there can be case that there are some operations on the publisher side, and since there is no logical replication there, so that data will be replicated once there is a connection between publisher and subscriber. So that's why we create tables on the tables which are creating during this time on the subscriber node. So data corresponding to that are being replicated. So yeah, next step we truncate all the tables and recreate the subscriptions. And yeah, that's how our logical replication is set up after upgrade. Now during this we observe some problem, like during the upgrade of the publisher we are not retaining the logical replication slots, and so we have to recreate it and we have to advance the LSN for that. And also the same issue we face during the upgrade of streaming replication, we are not maintaining the info of PG subscription rel, so we have to drop the subscription truncated table and recreate the subscription. So in PG17 we introduce a new feature, like during the PG upgrade. Yeah, so during the PG upgrade, that replication slot will be migrated. So it will be migrated like with the means during the upgrade, the PG subscriber will visit the old node and it will see the list of the logical slots on the old cluster, and corresponding to each slot, it will create a new slot on the new cluster. So that's how logical replication slots are migrated from old cluster to the new cluster. So now after upgrade, since we have that replication slot, we just need to change the connection string on the application side to the connection string of the upgraded publisher instance. Now let's see the next steps. These steps which we follow now, which we would follow now. So we have an initial setup of logical replication in PG17, and we want to upgrade it to PG latest. So yeah, so what we do, we disable all subscription because we don't want the connection between them during the upgrade. Now we just stop the node 1, the publisher node, and upgrade it, and it is upgraded to PG latest, and we don't need to follow the additional steps of recreating the slots. And now we simply stop the subscriber node and we upgrade it, and yeah, here also we don't need to do the additional steps of recreating the subscriber. So yeah, after that, yeah, during the process of upgrade, if there is any new tables are inserted on the publisher side, we need to create those tables on the subscriber side. And yeah, now just we need to enable and refresh subscription for all the tables, and the logical replication will be set up. So that's how its upgrade of logical replication cluster can happen. Now I will call Nisha on stage for the next topic.
Thank you, Shlok, for explaining all these complex steps of upgrade. So let's move on to the final part of the presentation, and here we will discuss the features came in PG17 to help the high availability of replication clusters. So let me start with explaining an important entity in logical replication, which is called logical replication slots. So whenever a logical replication is set up between two nodes, so at publisher node we create logical replication slot, and all the replication happens via that slot only. So this diagram here presents the step taken at publisher side when replication goes through. So first the whole record gets decoded using logical decoding, and then transaction will be stored in reorder buffer, and as soon as transaction commits, all the decoded changes gets transferred to replication slot, and from replication slot then subsequently gets transferred to the subscriber. So I won't go deep in details of this step because that itself is a huge topic. So our focus here is where this replication slot comes into picture. So to continue the replication between two nodes, the slot plays very important role. It ensures that the WAL files doesn't get removed from publisher when if that particular part of WAL file is not yet sent to the subscriber. And it also contains an output plugin which is used by logical decoding to determine like how the whole decode output will look like. So these are the slots, and next see how the high availability of clusters comes into picture. So we have real time scenarios called failover and switchover. Let me explain what is the main difference. So failover is the automatic process of switching to standby server when primary server goes down, whereas the switchover is the planned and manual process of switching standby server to the primary server. So whenever a failover or switchover happens, the high availability of the cluster is ensured by making the standby node as primary node as quickly as possible, and the time taken in this whole process is called the downtime of the server. So let's see how we can improve it. First, let's see what are the all steps involved whenever a failover happens. Suppose we have a setup where we have 3 nodes. Node 1 is the primary node, and node 2 is the standby node for that primary node, and we have a third node or subscriber which has set up the logical replication from the node 1, and it is using logical replication to replicate its data. So next, let's see, failover happens, and as soon as the primary node goes down, the logical replication between node 1 and node 3 breaks, and as per the failover process, we will promote node 2 as the new primary. So once this node 2 is promoted to new primary, the subscriber has to set up its logical replication from this new node, and to do that it has to follow some steps, which is first disable all subscriptions, then truncate all the tables, and then recreate all the subscriptions from the node 2. So then only a logical replication will be started from the promoted node, that is new primary. So this is the process till now to when failover happens. So we face some challenges during this failover process. So as soon as the primary node goes down, all the logical replication slots are lost, and the subscription can no longer continue. That's why it will have a service downtime, whatever application is using the subscriber. So to resume its logical replication, subscriber have to recreate all those subscriptions, and that itself is a very time consuming and error prone process because it's involve manual handling. And as Shlok already explained, this resyncing of large data set uses copy command internally. So this initial sync will again take a large amount of time when we will re-establish this logical replication. So to overcome these challenges, a new feature is introduced in PG17, which is synchronization of slots to standby node. The main aim of this feature is to synchronize all the logical slots present in primary node to the standby node. So by doing so, it removes the need to recreate of subscriptions and to resync the data. By this, it will minimize the time required in failover and will also help in continuing the logical replication with minimal disruption. This feature also guarantees that when this switchover happens, the newly promoted standby server is not lagging from the subscribers. And to achieve that guarantee, it introduced a new GOC parameter, which is standby slot names. So this is a list which contains standby slot names. When this list is set on primary node, wall sender will make sure that all the standbys have received the data before sending it to subscribers. So that's how it will ensure that whenever logical replication will be re-established, it's not lagging from the subscriber nodes. So next, okay. So next, let's see how to configure to use this feature. So now in PG17 there is a new property is introduced for slots, which is called failover. So whenever this failover property is set to true for any slot, that slot becomes eligible to synchronize. And how to set this? It can be set during slot creation, either using create subscription command. We can give the option failover, and or while using pg create logical replication slot function, we can pass the option as true or false as needed. So if user doesn't specify any value for this failover during the slot creation, by default we set it to false. That means the slot is not eligible for the syncing. But once slot is created, it is we can also modify this value. So we can modify by first disable the subscription, then set it the failover property to false or true, whatever is required, and then enable the subscriptions again. So these are the configurations required for this slot. Next, let's see what are the configurations are required at standby node to support this feature. So first is the standby node must configure the primary slot name in its configuration file. Next, this parameter hot standby feedback must be enabled. And third, a valid DB name must be specified in the primary coninfo. Then only this feature will work seamlessly. So this is how the conf files of standby node will look like with these settings. So once all configuration is done, now how to sync all the slots? There are two ways. One is manual, which is by using a new function pg sync replication slot. User can call this function on standby when required, and all the slots which are eligible for sync from primary node will be synced to the standby node. When this function is called, a process will connect to primary, and it will get all the information about whatever slots are eligible to sync, and then create the same slots on the standby node. Now, next way to sync the slot is the automatic sync, because because the purpose is for failover, and we want that whenever failover happens, we should have the standby should be up to date with the primary. So to enable the automatic sync, we need to set the parameter sync replication slot GUC as true. Once this parameter is set to true on the standby node, a sync worker will be started, and that worker will connect to primary on regular intervals and keep syncing the slots time to time, so that standby can be in sync with primary node. This sync worker will also be responsible for dropping any slots locally which are no longer applicable for the synchronization at primary node. And in case primary becomes bit inactive, that means no new slots are getting created, or no new updates are happening on slot, then it will go to a sleep, and this sleep time is tuned according to how active the primary node is. Okay, so once all these slots, the logical replication slots, synced to standby node, user can see, user can differentiate what are the synced slots and what are the non-synced slots. So to differentiate that, this feature introduced a new flag called synced in this PG replication slot view. So user can query this view, and if he or she sees that this synced flag is set to true, that means that slot is synced from primary. And for such slots, there are some rules which needs to be followed. These slots cannot be dropped by user or consumed, and no logical decoding is also allowed on the synced slots. And if any invalidation happens on the primary node for a slot, the same applies to standby node also. And in a case, say the slot is valid on primary, but it gets invalidated on the standby node, then the worker will drop it, and it will be recreated again on the next sync cycle. So that's how it keeps the slot in up to date with the primary node. So with this feature in PG17, let's see how failover will work. Say same setup, 3 nodes, 1 primary, 1 standby, and 3rd subscriber node. So as soon as primary goes down, logical replication breaks between node 1 and node 3, and for as the process we will promote the node 2 as new primary. Now to restart its logical replication, node 3 have to follow only one step, that change its connection information from node 1 to node 2. As soon as it changes its connection information, the logical replication will start. And there is no time of recreation of subscriptions and resyncing of data. And that's how this feature can help in reducing the time in failover process. So this was the feature, and here are some documents which for more details of these features. And to summarize, we in PG17 there are 4 new features under logical replication, which helps in minimizing the downtime during upgrade and ensures high availability for failover options.